Welcome to another RDWorks Learning Lab. Today I'm going to be doing something that I've been promising myself to do for a long time, but I keep getting distracted on so many other things like dots, pictures and memories of my girlfriend. Anyway, that aside, today what I've got here is a one-piece tube and mirror assembly that I designed for the light blade machine behind me. I designed this out of frustration because I found it quite difficult to set the light blade machine up. I'd like to put it on the light blade machine, but I have got a bit of a training video commitment to Think Laser. Until I finish that commitment, I'm afraid I'm not going to be fitting this on the light blade machine. But having done all the thinking and all the design work, what I'm going to do is adapt this fundamental design to fit on this China Blue machine, because although once you've got your mirrors set up, you don't really need to make major changes to it. When it comes to it, it's still a bit of a pain. Now, I've already made this machine quite simple to set up, but this would make it even simpler. So today we're going to step through the exercise of modifying that design to fit this machine. Now, I've done all the fundamental thinking and the design work for it, but adapting it to this machine is not going to be a complete walk in the park. The biggest problem that I've got is this machine capability is only 500 millimeters width. Technically that means I should be limited to designing parts that are no more than 495. Come on in and I'll show you what I mean about the problems. Well, here is a basic summary of my tube. We've basically got a 1250 millimeter long 70 watt tube. Now let's just assume we've got roughly 25 millimeters of bulbous bits at the end. That leaves us with 1200 millimeters in between. Now the correct theoretical support points for the clamps is what they call quarters. So that would be 300 million from this end, 300 million from that end, leaving 600 in the middle. The basic principle is if I was to break that tube in half, there would be a balance point here. In other words, this bit would balance out that bit. So basically, when you do that, you've basically got a stress-free mount. Now that's not technically true, and anybody with any metrology experience would understand that when they talk about airy points. Let's get into that sort of detail because it's not important in this particular instance, because we're going to break all the rules. We're not going to be transporting this machine halfway around the world in a container, and we're certainly not going to be moving this machine around with its tube in place. All the rules will get broken because, first of all, I would need a base plate 600 and maybe 620, 600, let's just say 650 millimeters long, so that I could mount the clamps at that sort of position. The problem is I've only got 500 cutting width on this machine, and that means I'm limited to probably 495 for the longest component that I can cut. So now comes the design issue of how we're going to break this job down into pieces that are no longer than 495 millimeters long. As we can see at the end of the machine here, I've got a long extension box. My clamp system that's been in there for best part of 2 years now is 440 millimeters hanging out the end of the clamp. And then I've got roughly 600 millimeters between the clamps, and my current clamp is here somewhere. So what's going to happen is I'm going to have to compromise that front clamp, or put it more into the correct position by shortening this distance between the clamps to about, say, 480 millimeters. Now I've already measured my tube in several places along there, and I get approximately 55.6. And by the way, this is a very handy piece of kit. It's a digital caliper, which most of you guys will probably already have, but those of you that don't, if you go onto eBay, you can probably pick one of these up for around about 10 or 12 pounds. They're very cheap. they're certainly not tool making quality kit, but on the other hand they are certainly very, very accurate for the sort of work that you need to do here on this machine, and it's extremely useful for one of the other things that we're going to have to determine, which is the material size. I'm very fortunate in that I picked up some nice sheets of perspex here, clear perspex, free because they were offcuts from one of the people that I deal with. Now perspex can be a funny material because depending on what sort it is, it can have wildly varying dimensions. Now this corner here is 5.88. I'm just going to go around and check all the other corners. So I'm going to take another, I've got 2 sheets here, so I'm going to finish up with another 7 measurements. Now this is important information that we shall need to know. Now obviously this is designed as 6mm material, but it's come in with a total variation of 5.95 down to 5.72, which to be honest is pretty good, because cast acrylic you're likely to get plus or minus 0.5 millimeters, and I have seen worse than that. And that makes it very difficult to cut slots that fit nicely with the thickness of the material. So over maybe only 300 or 400 millimeters, you can get changes that are nearly to that extreme. In this particular instance, we've only got a variation of roughly 0.2, and that tells me that probably what we've got is extruded, because the tolerances on extruded material is tighter than on cast material. In fact, now that I hunt around, I've found a little bit of text which tells me that this is perspex XT, and I suspect the XT means it is extruded. The good news is we've got fairly tight dimensions when we come to cut our slots for making the joints on this job. The centre point of my mirror is roughly 60 millimeters beyond the end of my tube. So we've got a basic idea now of what the layout will be, but we need to look at it now from 2 perspectives. One of them is a plan view. Now it's always difficult to measure strange dimensions like this from the edge of that tube down to here, but there are some tricks that you can use, little bits of metal for instance like this, which I can do that with. I can touch the back of it on the tube and the front of it on that lip, and then what I can do is to measure 31.7. Then I can use exactly the same trick to measure the dimension between here and here, and the answer is 105.3. Okay, so there's the basic outline for our plan view. Now, when I say front view, I really mean back view, but it's the front when you view it from the back. So there's the floor of the enclosure. We've got a reference surface here, which is the... Okay, so it's only a piece of metal, and as you can see, it isn't exactly very stable, and consequently there is still a possibility, if you look here, that the tube can move relative to the mirror. So this is not exactly the most stable mounting. It will do for what we want, because we're going to make it more stable, because we're going to mount the mirror and the tube on the same unit. It's just possible that with vibration this tube could move relative to that mirror. I'm pretty confident it doesn't, but it's just a design risk that you don't really want to take. We could mount off the back surface, but that's just as flexible. It's only a very thin piece of probably something like about 0.7 mild steel. It's pretty flimsy. But what we're going to do is I want to measure the centre height of this tube relative to this floor. Now that's, for me, it's very easy, because I've already got some packing pieces under here which I've used to make sure that my tube does not change its height. So I can measure the thickness of these packing pieces at 19 millimeters. 19.1. And that dimension there to the bottom of the tube is 19.1. And what we're really trying to find is the centre height of the tube. And the centre height of the tube is obviously 55.5 0.6, divide that by 2, that equals 27.8. We then add on 19.1, so that 46.9 is the centerline dimension. Now I think that's most of the information that we need to know to start work on doing some basic layouts in the CAD system. So let's jump onto the CAD system and make a start. Okay, well here is the basic picture for the light blade version that you saw on top of the machine. Now certain parts of this I should be able to adapt and use, but basically I think I've almost got to start from square one and redesign 80% of it. This was made from 5mm material. The stuff that we're working with now is 5.7 or 5. Yeah, just call it 5.8. So I'll just go away and draw the information that we collected. Okay, well here's my sketch drawings laid out to scale in the CAD system. We've got the back wall, the front lip, that being the plan view, and then we've got this view from the back which shows the floor, and on the right hand end we've got the mirrors, or the mirror 1. Somehow we've got to link mirror 1 to this module that I've drawn here, which basically is a base plate, as you can see, 493mm long, and it's got the clamps on it. Now the first question I've got to ask myself is, will my existing clamp system work on here? Because the clamps are designed to also take an 80mm tube, and I'm not so sure the 80mm tube will fit in there. Okay, so now what I can do is draw a line from here. Now that is very tricky. How am I going to deal with that? I know how I'm going to deal with that. We will put a large tang across the middle, offset, and then we'll offset that line by say 25mm. Let's see what that looks like. That looks good. Well, yeah, that's going to be tricky, but that'll be strong enough by the time it's all glued down. That center tang stops it from falling apart. Now this notch here is at the front, and what I want to do is to make the front touch the lip. My 80mm tube, well, it might physically just fit in this machine, but this system will not, because the back wall gets in the way. So if we take a look here, F6, you'll see that the clamp collides with the back wall. This doesn't stop me using this design for my tube, I don't think, because I've got adapters here. So that basically means that what I'm now going to have to do, okay, so that will work, because what we can do is this. We can move that now from there to F6 to F6, and there we go. That's a folding clamp just to suit my tube. It's not for anybody else's larger tube. It's only for a 56mm tube. Now I'm not going to get too worried about the top clamp at the moment, because that's a secondary issue. We can make that happen. So somehow we've got to put some stiffening sidewalls on here. So now I've got 5.8 as my material thickness, 5.8. And that means realistically that's about as far as I can go down. F9 for an intersect. There and there. So that's the height of my sidewalls. Now I can see this clearly in my mind, even though it's just a jumble of lines to you guys.
Sorry about that. So now I've got to trim it, and perhaps it will begin to make a little bit more sense when I trim it all up. Okay. I think that's going to work. Now these are subtly different in height. So I've got a little notch in there. That's the back one. And this is the front one. So there we go. We've got our two side stiffeners now. We haven't guaranteed that it will sit upright. Although these hopefully would do a pretty good job, we can't guarantee the material thickness. Now it's all very confusing at the moment. So let me take some of these lines out. Up there. This is the base unit, remember. So now I should be able to delete that and that, leaving a rectangle behind, because that's where I created a rectangle. And there we go. I can take these out. No, I can't. Yes, I can. And then I can mirror these. About the centre line. F7. Keep the originals, yes. So what I can now do is trim and take those bits out. Now pink lines represent construction, but if we join all these bits together, if I'd say join, I should join everything up, convert them into green. There we go. Do the same with this one. Join. We've got the tube mounted now, but what we haven't done is connect the tube mounting to the mirror. And that's going to represent quite a big problem, because we've got to jump a long way. Okay, now I've now added in the mirror assembly that I bought off of eBay for about 10 or 12 pounds each. Now I've thrown away a large part of the mirror assembly, and all I've kept is the mirror head itself, the mirror frame. It was on a stand with an adjustable base. I don't need it. So I bought two mirrors, and I haven't as yet decided whether I'm going to change mirror 2 or not. I think probably the answer is yes. The first stage will be to build this assembly. We'll get this set up, and then we'll consider what's going to happen to mirror 2. Here is my mirror. This is a side view of it, and as you can see, the base plate stands about 0.7 of a millimetre lower than the actual mirror plate itself. So that's the base upon which I've got to mount the mirror. And here it is. Here's the level. Now, looking above into the plan view, between the tube mount and the mirror, I've got 416 millimetres. Well, that's great, because bear in mind, I've got 500 mil that I can play with to make pieces on the machine. So I'm nowhere near any sort of limits. The problem now is, how are we going to link this mirror plate solidly with the tube? I think I'm going to have to revert to a tried and tested method of joining things together. And I'm going to draw that line from the centre point there to the centre point there. And then I'm going to draw a circle. Centre diameter, choose a number, 8 maybe, 8 millimetres. Yeah, that looks about right. And then we'll plonk that down in the middle there. Then we'll draw a line, F8, which is the centre of the circle. And we'll probably do 2 offset. Yeah, that'll do. And there we go. We've got a jigsaw puzzle joint. Okay, so let's assume that where I've got this is going to be the end of my mounting plate. So my mounting plate can't be any wider than that. We'll draw a line from F7 perpendicular to the edge, and a line from the center of that perpendicular to that edge. Then we do a copy of this from its center point, F8, center of the circle, and we'll plonk that onto the center of that line at F7, and on the center of that line at F7. It looks a bit weak, but it is 6mm material, and it will all be finished up glued together, so it'll all be locked back up into a solid lump by the time we've finished. Now what that is, this is a location stop and guide to make sure the mirror frame sits exactly at 45 degrees. Now I could be a coward and I could change that to a slot so that I could slide my mirror to left and right. So that's the plate fixed to the base plate. That's the mirror plate fixed to the base plate. Now we need to put the side plates on. Well, let's draw a side plate and then we'll modify it afterwards. So we'll draw a side plate like this. We'll start off at the same height somewhere. So it doesn't matter where they are because I'm going to make notches to match. So now we join these up again with a line from F6 to F6, F6 to F6, and then we've got this here, F6 through to there, and then we put a fillet on it. There, and a fillet on there for the moment. So there's our side piece, the back piece anyway. We've got to do the same for the front piece. So that tells me now where this mirror plate is going to lock. Now the base plate is going to come right along to the bottom here because I'm going to decide that. Then this side plate, does it get in the way of anything? I've got to make allowances in there somewhere for my water pipe to come out, and I think it's got to come out downwards. So I better go and have a look to see where my water pipe comes out. Okay, well I've been away and checked. I've got to leave space for the cathode wire and also for the cooling to come out. So that's why this side plate is now in two pieces. Now, in addition to that, what I've done, I've mounted the mirror plate in here as well. So the mirror plate is now at the correct height, and here is the mirror plate with its tabs on it. We've got to look at the possibility of putting a red dot pointer on here as well. Now, I don't know whether I shall have space to do that. So to assess whether or not we can or cannot do that, I think I shall have to draw another view. I've had to draw an end view of the enclosure to find out what space I've got to move the laser pointer out of the way. Not a lot of room, but there is just about room in there for me to put a micro switch to detect the end of the stroke right at the top there. I've got a little bit to play with, as you can see down here, because this small inner circle is the window where the laser comes out. So I've got a little bit to play with before the window closes, and I could possibly cause a problem, but I don't think that's going to happen because the micro switch at the top here will sense it as soon as it pulls away, and it will cause the water protect circuit to cut in and stop the laser from firing. Now it's really down to just designing the small piece that takes this element here which is very similar to the tube mount. Well, I do believe that's all the parts for the Mark III. So I'm going to delete the parts for the Mark I. And now we're going to sort out the parts for the Mark III and lay them out on a sheet. Okay, so we just need to save this section here now as a DXF file, and we'll see it appearing in RDWorks when we import it. Quite a few pieces on here that might possibly fall out and move, so I think we'll do the pieces one at a time. Mark those two holes there as a group. No holes in there, no holes in there, two holes in there. We'll put them in as a group. And two holes in here, which we'll put in, three holes in here, which we'll put in as a group. Actually, we'll just set the parameters before we start. They're all cutting. Speed, I think we can probably go at about 6 millimeters a second, and we can run the machine at 68%, I believe. Blowing, yes, we'll have blowing on. Cut mode, yes, and that's it. Okay, so we'll now sort out how we want these things cut. We'll have those slots cut first, then we'll cut the outside shape. Then we'll do this one, then we'll do this one, then we'll do these holes here, then we'll do the outside shape. Then we do holes there, oops, holes, and the outside shape. And there we go, that's all sorted. That's how we want it cut. Group that block of holes there, and while we're there we can add that hole as well. We'll put them into a group. Put those two holes there into a group. For all the holes on there into a group. Those holes into a group. So we can now order this lot. We'll do the holes first. I could have done these shapes as a group. I didn't do them as a group, but I could have done them as a group. Then we do these two here, followed by that one. And then we do that one. Whoops, no we won't. We'll do those holes next. Then we do that. Then we do the holes in there. And that. Then we do that. The holes in there. That. And finally that. And that's that sheet ordered. We've already got the cutting parameters set. We'll now just save to U file. Okay, let's go to the machine and get cutting. Well, this is 6mm acrylic that we're cutting here. And I've got it sitting up on my steel plate with 6mm spacers underneath. So when the material drops, which some of it hopefully will, it won't drop out of position. It drops one sheet thickness only. You can see the way in which the smoke is being drawn out from underneath the job. And the fact that those fumes are not catching fire But you can see we have got some debris on the surface of the nozzle, which I really ought to clean. Can you see how that? Can you see how that is actually sort of glowing? That's heating the nozzle up and taking some of my power away. And there we go. The pieces drop out cleanly, and they drop down into perfect position. They don't drop out and overlap each other. Yes, I can see the reflection. It's just a piece of debris sitting on the surface, probably just on the edge of the nozzle, that's causing that glow. Well, there's the first set of parts done, and the only thing that's holding them in is the fact that the acrylic is probably a little bit hot and sticky, because I've tried to get a smoothish edge on them. So they're actually all free. And it's running at about 21, and you can see the temperature is actually shooting up quite a lot. That's the water temperature, that top one, and it's nearly at 40 degrees C. Now, I don't like to see it run over 40 degrees C, because I know that there is likely to be a loss of power. But having said that, it's still cutting perfectly fine. No difference between the beginning and end of the sheet. Well, this is the last part. We're just coming up to the last little part, and that drops out as well. 40.9. It's not that they haven't cut, they've all cut cleanly. Well, we'll go and take all the plastic off, and then we'll have a go at maybe trying to assemble some bits.
Well, here we are, ready to rock and roll with the assembly. A couple of things. First of all, I don't need this temporarily. I'm still fully awake, I think. The glue that I'm going to be using is the same stuff that I've been using many times before. It's by a UK company called Bondrite, but I do believe that they're also in the States as well. This is a PETG weld cement. As you can see, it's coded up WC123. This is obviously not PETG, this is acrylic. Originally I purchased this for a PETG job, and when I spoke to him about using it for acrylic, he said yes, it will work okay, but it will take a little bit longer to bond. Well, it only takes about 30 seconds to a minute to bond enough to hold strength. Full strength, I think, probably takes best part of an hour or so. Now, this particular acrylic is extruded acrylic, and from all accounts, extruded acrylic is very prone to crazing when you cement the joints together. So, you know, we might finish up with hell of a mess here, but I'm hoping that from previous experience that we're going to get some good clean joints. Because this is not proper acrylic cement. Obviously, this whole assembly has to be built flat and in line, because I've got to make sure that the tube, which is on one piece here, and the mirror, which is on another piece here, all line up. So to try and overcome that problem, first of all, I've used my spare piece of acrylic here on a nice flat surface. And the reason why I'm using this is because it's got a plastic film on the top, just in case I drop any glue on the surface. So it is a nice flat surface, relatively speaking. And also what I've got here is a piece of stainless steel tube. Now this is a lovely, just a piece of surplus tube that I had left over from a job. But the great thing about it is it's like a great big straight edge, which first of all, as I press it down, guarantees that it's flat just where I'm going to build it, and secondly I'm going to be able to build against it, so that I can guarantee that it's flat in this plane along here. Now, something that you didn't see me do is I've put some additional holes in here, 3 holes. These holes are drilled 5.2 and they will actually appear on the final DXF file, and they have been tapped M6. Now, this is a particularly tough material. It's much tougher than cast acrylic, and it's produced some really, really nice, clean, shiny edges on it, really well mirror polished. So I'm very pleased at the way in which this has come out, considering I did this with air assist as well, but I did it with a 2-inch lens. So basically there wasn't too much of the air passing down into the cut. Most of it, because the nozzle was 3/4 of an inch away, most of it was dissipating across the surface. So yes, I got some really nice flame polished edges. Oh, just out of interest before we push on, look, the jigsaw bits fit together nicely, and although they do fit together nicely, look, there's sufficient clearance in there that it does float around. Now, that's not going to be an issue, because by the time we line it all up and I put glue in these joints, the whole thing will lock up solid in the position that I want it locked up in, which is perfectly lined up. Where do we start? Well, I suppose that would be a good position. We ought to assemble, well, I've assembled the base here, which is good, because once I put this on, as you see, I can't actually assemble these pieces. They sit underneath this notch, underneath this here. That's basically the assembly. What I want to do now is to build this piece here, because I want to glue the whole lot together so that it's one straight assembly. So I don't want to glue it in 2 pieces. I've already assembled my holder, my mirror holder, onto this plate. There's just one screw underneath there holding it, and I've located it against this little stop that I made. So we push the stop in there, and in fact it sits in there snugly. I've locked this up so that, yeah, that sits in there nicely and tight. Let's just do that to start with. I'll just put a little blob of glue in that joint there, and we can see it running in the joint. I have to say that I can't see it crazing. No, it looks like a perfectly clear water joint in there. That's a very nice joint. You must assemble these in the right order, otherwise you physically can't assemble them. So that one's got to go on first, then that one has got to go in next. Yeah, if we take a look just here, I can't make my joint properly because this piece here is hitting on here. So it doesn't quite work. So what I'll do, I'll just go back to the machine and I'll manually just trim that piece out. 5 minutes worth of work, and we've done a modification. So hopefully that should now fit on there. It's just like that. And this one fits on the other side like that. And that allows me to now adjust the mirror nicely. There, there, and there. So I want to just run along this joint here. So I'll hold that for about a minute. And that should then be stable enough for me to let go. So the only important part of this assembly is this back face, which has got to sit true and square. The front faces don't really matter, they're only stiffeners. Okay, so what we're now trying to do is to get this whole assembly square. At the moment, we've still got an element of float here. So what I'm now going to do, I'm going to lock up this joint across here. Now I suspect that's probably going to go through underneath, and I'm going to have to move that Well, that's looking pretty good. But I can see when I look down there, I can see just a little bit of crazing in the bottom there. It's not quite as clean as I thought it was going to be. Well, I have to say that at the moment is looking pretty good. Let's just see whether we can move it and when I've stuck it to the deck. No, I don't think I have. Okay, so all the glue has dried now and it's really nice and solid. We're getting to the point now where we need to just assemble the clamps, the tube clamps themselves. Pass a screw through there and we get that two-piece assembly. We'll just put a washer on the other side. And then I'm going to use a nylock nut. Now this is a self-locking nut that will enable me to change the tension. Now I want to be in a position where I've tightened them up so that they stay where I put them. But unfortunately, in my particular instance, because the back of my cabinet is here, I haven't got room to swing these open to get the tube in. Now what I've got here are some pieces of 8mm polyurethane tube. I'm using these because they are nice and flexible and they will compress against the tube without doing any harm. And then we've got this piece here which is the catch. So first of all we'll pop these into place. 1, 2, and they just snap into place like that, and this one snaps into here and holds that together as an assembly. And then once we've got the tube in place, we just snap that in place like that, and the whole lot is nice and flexible. You know, it just compresses the tube just a small amount without putting too much stress on it. So there's our tube mount now, very simple. Well, I'm going to remove the, if you like, the Mark 7 or the Mark 6, they're one and the same. I think it's even the same as the Mark 5 red dot pointer from its background piece of material that was used for the light blade machine. And I'm just going to use that quickly on here instead. Now, one thing I want to point out to you is that I use elastic band on here because it's a lovely flexible material, but after a while, look, you can see what happens to the elastic band. It oxidizes and it goes stiff and breaks. So yeah, by all means use an elastic band because it's nice and simple and very flexible, but you may well have to replace it every month. Okay, so I intend to replace the rubber band with a small tension spring which I've got, which is, as you can see, nice and flexible sideways and in all directions. A notch to the front where my thumb is, and this piece to the back, because we're going to build it from screws from this side. Now these screws are M3 by 25 long. We need to tighten those screws up. So now I need to modify this with a 5mm hole just here so that I can take my spring. Okay, so there's my 5mm hole in there now, and we'll pop this on there, and that should now float around. So we'll put our adjusting screws on, small washer underneath there, spacer, and now our spring. Now, because I mess around with pneumatics, I've got all sorts of bits and pieces around this shop, and one of the things that I've got is some 4mm polyurethane tube, and 4mm polyurethane tube is just perfect for what I want. I'm going to cut a piece off, and look, it's just a perfect snug fit through that eye, which means I can pop it through there, and then I'll cut another piece for the back. And now I've got a slightly tricky situation. I've got to pull the spring through, so that I can get my piece of tube on the back as well. And there we go, we've got a nice floating assembly. I'll just tuck the wire under the little clip there to keep it out of the way. Now I'm not going to use a washer on here because this is just about the right length. I need quite a lot of tension on this one. I don't want this to move once I've pulled it into the up position. I need to make it quite stiff. Now that's really nice because it means it's sitting flat against here as well, which is what I'm trying to do. Now I haven't got a mirror in there at the moment, but it doesn't matter because when I push that forward, that ring is sitting in the same place as the mirror would be at the front there. So hopefully this is going to be my perfect setup. And because I don't use the beam very often, I'm just driving it with a little battery box. We just need one last thought. Is there anything else that I need to do? Because once I take the laser beam out, I'm stuck. Now most of you guys don't have the luxury of a spare machine to fall back on if you get the design wrong. So think before you commit to take your tube out, because otherwise you'll have to put your tube back to make any modifications. Twice the work. Well, I'm just taking a break, but to be honest I think we should all take a break and conclude the session just here. Now I was hoping to get this done all in one go, but hey, that was a bit ambitious, wasn't it? So there will be a few days yet before we can find out whether this cement helicopter flies when we push it off the edge of the cliff. Now I'm sure there will be a few problems, but hey, nothing that we can't wiggle our way out of as we go along. The biggest problem will be once I take the tube out, will I find anything else that I need to do? Hey, that's the fun of this hobby. So until the next time, cheerio.